Alright, so I hope it is the very life. We is very life. So the most important news is that my beautiful girl is talking to me again. Just a little at this time. She initiated a hi, how are you text, which is an accomplishment because I thought I completely destroyed the relationship. Where is my remote fan? Where I'm traveling, it's really hot. It's only Jesus knows how hot it is. It's really hot. Oh my god, I'm so hot. I'm tired. Also, I'm tired. Tired. Okay, so today the name of today's video. Well, let's check the audio. The audio come back. Listening. I don't know. Let me check. Oh, all right. So yeah. So she's in touch with me. Seems to kind of be this really have pictures already with you said and so first I overreact. That was not scientific. That was a small, a tiny mistake. It dog shine. One, two, three, four, five, six, seven, eight, nine, 10, 11, 12. Reduce mic background. Absolutely nothing. Dead. It's dead. It's totally dead. Nothing. I can hear that. Before I could hear something, but now I can hear nothing. Let's add automatically adjust mic volume. One, two, three, four, five. One, two, three, four, five. One, two, three, four, five. Yeah, I mean, I can see that the mic on StreamYard has zero sensitivity. One, two, three, four, five. So it's zero. Now it has a little bit of sensitivity. One, two, three, four, five. Basically zero sensitivity. One, two, three, four, five. One, two. The mic has zero sensitivity. No matter what I'm doing, the mic has zero sensitivity. question is this coming from the laptop itself? So this is the speed to the mic. The mic is very low. One, two, three, four, five. One, two. Let's raise the mic to the maximum. One, two, three, four, five. One, two, three, five. Okay. It's up, down. Terrible. Just terrible. Terrible. Let's raise the mic. StreamYard to maximum. Mic is on maximum. I can use the mic very badly adjust. Four, five, five. Yeah, the mic is back low on my laptop. Can I tell it to stop bringing the mic down? What's going on here? It keeps going down and down. So yeah, so don't automatically adjust. One, two, three, four, five. One, two, three, four, five. One, two, three, four, five. It still automatically adjusts. I told you not to adjust. It goes up. I raise it up. Okay, let's cancel everything and just tell it to. It goes to 8 out of 100. Of course, we're not gonna hear it. Now, now I told it don't do any correct. I told StreamYard don't do any corrections. Still, the audio goes down automatically. Yeah, it automatically goes down on my laptop. And this is when I'm telling StreamYard to not correct. Like I removed everything. I removed echo cancellation. Removed everything. Let's maximize mic on StreamYard. Maximize mic on laptop. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 1, 1. It keeps going down. It goes down on the laptop. On StreamYard, it stays max, but on the laptop, it goes all the way down to basically zero. So I don't know what's going on. This is not good. Not good. Not good at all. At all. At all. No good. No good. I don't know what to do with this. What am I going to do with this nonsense? It's automatically adjusting the mic. Choose where to play sound. That's not the problem. The problem is the input. Here's the input. The input. So if I go to microphone array, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You know what? Let me go into the settings of this nonsense. Allow apps and when to use this device for audio. This device currently in use. Changing any properties during use may cause audio application issues. Okay. Oh, now it went to very high number. Oh, 100. Result, 1% of total volume. Oh, yeah. Now I can hear myself. Start test. 1, 2, 3, 4, 5. Stop test. Result, 15% of total volume. What? I don't know what's going on. This is so confusing. So confusing. Like, really weird. Like I happen to be an expert in audio tech. Like I was actually an audio super tech, like a very deep tech. Check for driver updates. I don't want to go into what I used to do, but I am a top-notch expert in this field. Okay. It sounds like it's okay now. Top-notch. How long have we been here? We've been here for about 10 minutes. This is 10 minutes of nonsense. My God. I don't want to restart the stream because it's going to screw up again. I don't know what to do with this nonsense. Okay. Yeah, but I'm hearing an echo. Why am I hearing an echo? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Yeah, I'm hearing an echo, so let's do echo cancellation. Okay, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115. Oh, much better now. Okay. Like normal. Now it's normal. Now it's normal. Now it's normal. Still a little background noise. Let's reduce background noise. Okay. 201, 202, 203, 204, 205, 206, 207, 208, 209, 210, 211, 212, 213, 214, 215. Oh my God. It's destroying my audio. Oh my God, this is so bad. I don't want to use this. Like the StreamYard is destroying the signal. Let's try this again. 301, 302, 303, 304, 305, 306, 307, 308, 309, 310, 311, 312. Yeah, I'm able to hear an echo. We gotta go with echo. Echo will use, but reduce mic background noise. We're not going to use. It's nonsensical. 401, 402, 403, 404, 405, 406, 407, 408, 410, 411, 412, 413. It's still very noisy. I don't know what to do. This is garbage. This is utter garbage. What is going on? I don't know. I'm gonna leave it like this. Just echo cancellation today. Okay, at least there's no echo. That's a good start. Okay, we're just gonna remove. I don't want to hear myself in the background, obviously. All right, so we need to do research. What is the smallest Michelson-Morley experiment? Nom, 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 nom. What is the smallest Michelson-Morley? I mean, the smallest device. So we saw yesterday that nom, nom, nom. If we build a device based on the color red, in order to get normal wavelengths, ticks, it's got to be a kilometer or the arm. Well, we need 300-meter arm to get something like a single tick over 90 degrees. I think that was basically the calculation. So let's now try and find maybe smaller wavelengths. The color red is 0.65 micrometers. Maybe we can get smaller wavelengths and therefore reduce like the size of the device. So a big device that is 2 kilometers high and needs to rotate, it's going to deform. And this deformity, it's going to give us wavelengths in of itself, just because of the deformation of the physical device. And there's no way we can measure. Maybe there is a way to measure. We can use literal stress sensors. We can put stress sensors on this huge device. It's going to be too big. I mean, this is not for our generation, obviously. I mean, whoever is going to conduct this experiment, you can build a device in outer space. in orbit, and then you don't have any problem because in orbit you don't have any deformation. So if you can build a 2 kilometer arm, that should be very straightforward because it's going to, you just need a wire, a literal wire. You can build this device out of 2 wires. Okay, so if anybody wants to conduct this experiment in space, that should be straightforward. And it should give us proper results. We will measure the speed of the ether, even though we are in orbit. Flying as fast as we are, that has no bearing on the fact that the ether is flowing through us towards the center of the earth. We should still be able to measure it. Oh, no. We have a vector. We need to consider the fact that we're flying through the ether at 25,000 miles an hour or something. So how close is that to our 10,000 meters per second? So I don't think that in space we fly close to 10,000, but as soon as we start flying in high speeds, we need to account for, like, the vector needs to be accounted for. We can't just ignore. So so the first thing we need to check is if we build it. Let me first show you how to build it in space, and then if you have the money, you can, like Elon Musk can easily do it. It should be very cheap. This should be very cheap because inexpensive because it's a very lightweight experiment. It's a tiny laser that you buy at the laser store, at the dollar store, a keychain laser, like a cat. The game, like you play with the cat and a laser, and the cats go bananas. So that type of laser is $1, and then you need one semi half reflective mirror. Those you buy at like optics stores or probably online. Maybe Amazon has a kit. So we need 2 full mirrors, 1 half mirror, and a detector. The detector is just going to display the laser beam. You're going to use a red laser beam. That's the simplest, so that you know the wavelength. It's 0.65 micrometers, basically. You can test it in the lab. You can calibrate and make sure that is the wavelength. All right, so this is space-based. It can be in orbit. Space-based michaelson-morely. Okay, that's it. Space-based michaelson-morely experiment to detect the speed of the ether. All right, finally somebody is going to detect the speed of the ether. Somebody has to do this. Because, I mean, this completely, thoroughly debunks Einstein and relativity as a not completely unscientific theory. It has nothing to do with science, complete nonsense. Relativity is just wave theory, just wave mechanics. It's really very straightforward. It has nothing to do, there's nothing special about the speed of light, except for we are made of those particles that move at the speed of light. So that's all. But as far as our clocks, well, because we already spoke enough about that, and dialect already explained it. Here is, right, it's this video. It's what time dilation actually is in relativity. Hint, it has nothing to do with time. Yeah, it's just a clock ticking. And you can say that atoms and subatomic particles are, you could say they're ticking. You could say that if like a light beam bouncing up and down, that's a light wave. It's a wave of the ether. So that has nothing to do. It's not nothing to do with time. I would say nothing to do with light. It's just the speed of waves through the ether. Let's get back to our space-based love of my life. Let's see what she says. Oh, she wants to stop. Oh, she wants to stop. Oh. it's the end. It's the end. The end of the universe has arrived. Yeah, I screwed up way too much. Way too much. Way too much. Way too much. Mm. um. Let me just tell her if you need me. If you need me anytime. Mm. Mm. So obviously, I'm not giving up. So she wants to break up. It's fine. It's fine. Let me turn on the air conditioning because I'm melting down. So I'm not giving up. I'm gonna keep trying for a while. Keep sending her here and there like messages, and she if she's going to make me give up, then fine. It will happen. Whatever. It's it's fine. I'll get over it. All right, let's continue. See, we have a message here. That's a good thing. What's a good thing? Is it bad though? I mean, the case I always heard was there's a lot of people in gay sex with lower procreation. That's a good thing. Oh my God. All right, whatever. Okay, so let's talk about the space-based Michelson-Morley experiment. Okay, so let's start from the Earth. So here's the Earth, and we're gonna build right. So we're gonna be in orbit. We're gonna need to look at the orbital speed, what it is, and what is its influence on the expected result. And basically, we need to construct the Michelson-Morley experiment in orbit. So let me put it here so it's easy. So here is going to be the Michelson-Morley experiment. It's going to be the same as always. There is no change. So here is the new orbiting Michelson-Morley. So we're assuming that ether is streaming down through the equipment, through the apparatus, in towards the center of the earth, basically. So this is the experiment. So as always, we're gonna have an it doesn't matter what, like if we have an emitter here, yeah, we could have an emitter anywhere. I think we usually start from here. So this is the emitter, E. And this is a semi mirror, a full mirror, a full mirror, and the display. Here we're going to get the display. Now this is in space. So in space, well, let's first draw the light. So one beam goes here, and the other one splits to here. And then this one goes back here. And this is green, so this color, let's say this goes to here. It doesn't matter right now which we expect to be longer, shorter, slower, faster. What we do expect, so the way to build it, I would say, is to have a string connecting everything to a central point. So this is connected, this is connected, this is connected, and this is connected. So it's just four strings, very lightweight, a laser pointer. So we don't need this circle around. This doesn't serve any purpose. That we don't need. We just need an emitter, a display, a full mirror, half mirror, and it's just wires, just one, two, three, four wires, very lightweight wires connecting them. And this thing is going to be set in motion. It's going to rotate. Hey, hamburger and fries, what's up?
Hey,
Eh,
how's it going, slave?
Terrible. I just got a message that this chick I was beginning to see, she told me that she's not interested in me. Not interested in me.
In debating you or just in you?
In my physical in me. In my physical
Okay.
me. She's not interested, so I'm devastated. I was devastated like 3 days ago, and then she started speaking to me yesterday, so I slept well. But now I'm devastated again. But now it's a dead end, so maybe I'll be able to sleep. So what do you think
Pardon me.
about what?
I burped. But yeah,
I didn't hear.
I was just thinking, like,
Hmm.
are you comfortable giving like a physical description of what you look like, or is that too intimate?
There is. It's not the problem of intimate. The problem is I don't want to get doxxed. So the less information I give about myself, the better it is. So, but I do give information to women that I DM. They have usually I give away my personal everything about me, but I don't.
Oh, I've been doxxed based off of some stupid information before, like even talking about like what bakeries I liked, or like when my actually I talked about my dad used to have a gas station after he got out of the Marines.
Mhm.
So I talked about it, and I found someone on eBay was selling a matchbook from his old gas station, like the free ones they used to give out
Mhm.
like at the cash register. And I was like, wow, I'd love to have one of these. Like, I thought they were interested in what I was talking about. They used it just to dox me, like, more intimately and find my house. So that was
Wow.
weird.
Yeah.
Yeah, you never know. Like, it's always when you're the most unassuming. And it's been like, oh, well, how do you like live your life then? Just trying to be friendly and trying to make connections with people. Cause like, I want to be able to tell that story. Like, I love my dad.
Mhm.
And that was cool. Like, we had a cool life. Um,
Mhm.
and like, my grandma used to work at a sandwich place. She actually had like a patented sandwich, and I was talking about it because I wanted to either name like a restaurant after it or use it in some sort of way. And then like someone was like, "Oh, we're gonna start calling everything that so that you can't do it, like, and then it won't be yours anymore." And it's like that was just malicious and just to like hurt my feelings. Like I wasn't even trying to make money off of it. It had nothing to do with that. It was just like the sake that it was my grandmother's.
Mhm.
So
Mhm.
people really get crazy, and it's usually out of jealousy. So men don't have to deal with it as much. I've noticed because like people are just jealous of women like more inherently, like they're jealous of them when they're doing poorly, and they like tend to think it's their fault and like, oh, good riddance, and then they try to crab bucket them so that they can't get out of that circumstance because they think that they just deserve it.
Wait, how do you?
And it's like
What
I
is?
don't
Wait,
I don't know how to be one of those women who doesn't deserve it. It's like too rigid.
wait. What does it mean to crab bucket? Never heard of this term.
Oh, crab bucketing. When a crab is in a bucket with other crabs, the crab can successfully climb to the top of the bucket to get out,
Mhm.
but the other crabs pull them down like inherently. So all of the crabs are pulling each other down so that they're just cycling to the top of the bucket and to the bottom of the bucket. None of them get out because the crabs keep pulling the ones that get to the top.
Mm.
It's basically like this mentality like if I can't have it, you can't have it. And
Mhm.
like so many guys have told me like, oh, being a woman is life on easy mode. Like when I'm literally homeless, I'll be like, hey, a guy like, gave me some advice on what to do today, like not even like a physical thing like money or like anything, and they'll be like, oh, because you're a woman, life is easy for you. And I'm just like, yeah, did you miss the part where I was homeless? Like, or like it just, you might ask for help or something, and then people are like, well, don't you have a boyfriend? Like, you know what I mean? Like they just assume like,
Hmm. Yeah, I
I
know.
don't know, women needing help or grifting in some way or something.
So I know. Like I'm usually in touch with very beautiful women, and I know how difficult life is for them. Like it's not easy mode at all. It's definitely not easy mode. But men think it's easy mode because men want these women so much that it must everybody wants you. It must be easy mode. You just go out and they give you money. Yeah, but how much do you have to text before you get that date? And sometimes they give you very little money, and on average, it's not worth it. Anyway, yeah, I know it from the inside how difficult it is. Are you there?
Yeah, sorry, my husband wanted me to put something in the microwave.
Hmm.
I don't know why. I think he just wanted it to be put away and figured if I like put it in the microwave, it would be like easier.
He wants it
He
put
said, "I
away.
took it, LOL, for work." Now I'm very confused. How can I put the pot in the microwave if he took it for work? What's going on? Okay, you know what? I'm gonna call him real quick and just see what the hell's
Okay,
going on. Because now I'm confused. I'll be right back.
okay, okay. Okay, so let's get back to this describing the space version experiment of. So just to remind you, you need. So if Michelson would have conducted this experiment in a lab, there's no way he would have gotten any positive result with his equipment. I don't see it. He would have had to be so accurate that it's just I don't see it. I just don't see it. Can't see it. He didn't. He had no idea what the speed of the ether is or the direction. At least I have a theory what the speed, and I can calculate very precisely the speed and direction. So it's about 10,000. We calculated about 11,180 or 160 yesterday meters per second at basically Earth's surface. So it's about. I'm 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 doing very round numbers because speed of light is not 300,000, 300 million. It's something close to that, but so I'm ballparking the speed of light. So everything. So I'm just using one digit. Um, hey, what's up?
Alrighty, I'm back. Yeah, he took the pot to work and then lost it and thought like he left it at home.
Mm, wow, took a whole pot.
I have these new ones. Yeah, these are convertible pots. Like you can take the handle off and you can put a lid on it like Tupperware.
Mhm.
But he didn't take the Tupperware lid, he put like tinfoil on it.
Oh,
I'm like, okay, like that's
that
men.
defeats the purpose.
Men will be men. That's
Yeah.
just how it goes. It's like when they put the whole crock pot, like including like the outside, like with the wire like in the fridge. But
The crock pot.
okay, yeah.
I don't know. I barely know what a crock pot. Yeah, what wire? Crock pot has a wire?
It's electric. It
Yeah.
has like a ceramic
Oh
pot
my god.
on the inside.
You
You
mean
take it.
the electric wire? Wow. Yeah.
Yeah, so you take the inside out if you want to put it in the fridge
Yeah,
or
yeah,
take
yeah.
it with you.
Yeah, I'm familiar with that. Yeah.
I love crock pots, dude. Like he told me we don't need one though, so I'm sad.
Wait, wait. So why do you like crock pots? What's the advantage?
Because you put everything in and then you just leave it and forget it for like the whole day. Like it's not a pressure cooker, it's a slower cooker,
Sure.
you know?
Yeah.
And so you can get some really good flavors in like your soups or your roast or like your pulled pork because then it gets to sit there all day
Yeah.
and it keeps things moist,
Oh.
not letting the humidity escape. So it makes really good pulled pork. I do pulled chicken with my grandma. Like, I don't eat meat no more, but we never ate pork in the first place. So I always did chicken as a substitute. And it would come out perfect. And you can even bake cakes in them, and the cakes come out like perfectly level.
Mm-hmm. No way. Cakes? I didn't know that.
You can make, yeah, you can put a cake mix inside the crock pot, mix it up, put it on,
Mm-hmm.
and it creates like a perfectly level moist cake. So you can
Mm.
do that and then just like have it be like perfectly round or like oval.
Mm. I see.
Sometimes that's nice.
Sure.
Sometimes it's just easy. Like it's just about the easiness of it. Like you do that and then you go to work, you come home and everything is done.
Amazing.
Like that's the easiest way to cook dinner. And then you just get like, bag of vegetables and then like a protein and then like, throw a sauce together. My favorite thing to do was make Irish cabbage.
Mm-hmm.
You let the cabbage like kind of steam in there all day
Mm-hmm.
with the broth, and then you have like cooked cabbage and like horseradish.
Mm-hmm.
It's
It's very
great.
interesting that women are into cooking. Like I don't think men.
I got really into like the domestic
Mhm.
like elements of like the 60s where they're just like, hey, we're gonna cook the eggs with electric shocks. Like, I don't know. I love shit like that. You know?
Mhm.
Like the convenience like oddities. Like I love that stuff.
Mhm. Fascinating. Anyway,
I
so
used to have a collection of Eggies, dude. There
eggies.
was this thing in the US called Eggie where it was just these little kitchen tools.
Mhm.
And I don't know if they were actually meant for like adults or not, but
Oh.
it would be like a whisk or like a masher, a timer, and I had like basically all of them. Whenever they came out with them, I'd have like a new one. So I had all these random little tools, and it's like an egg with like googly eyes and a beak and feet.
Mhm.
So all of them stood up by themselves. So I had like just this huge collection of eggies, and I think my grandma only kept the magnet.
The magnet
But I loved him. And then I had like a special edition Christmas one, and he sits on top of her fridge.
sits on top of the fridge. Oh, an eggie. I'm.
Yeah,
I,
he's an eggy whisk, so a whisk comes out of his head, and he just like sits there like a little guy.
mhm. Fascinating. Anyway, tell me. So do you understand how an apple fall? Why an apple like tends to accelerate towards the earth?
Oh, this is part of the water discussion from yesterday.
It's up to you. I mean, you tell me how why apples tend to speed up as they tend to fall towards the earth. Like, what's that all about? Like, there's no wire. How, I mean, there's no invisible. Wait, is there like an invisible? The earth grabs the apple with an invisible hand and pulls it in. Wait, how does that work? Can you believe no one knows how that works? Are you there?
Do you think, yeah, I was gonna say, do you think it's like brainwashing that everyone is going with like a NASA based assumption?
Like a what? What assumption?
A NASA based assumption, like a scientific assumption, but
No,
not just like scientific, but like
no, no,
science that was
no. No one
like
knows. No,
publishing by like one. Okay.
no one knows why an apple falls towards the earth. No one knows. No one knows. We just don't know. I mean, I know, but no one else knows. I mean, Einstein said it's because of the curvature of space time. But I think that's just gobbledygook. He had no idea. I don't know what he meant. I don't think anyone knows. I'm sure no one knows what that even means. I'm sure he didn't know what that means. But everyone just repeats what he said. It's so dumb. Have you ever heard of Einstein?
Yeah.
Have you heard good things or
I
bad?
wondered I wondered what you thought about him. I've only researched him as far as it pertains to him being autistic and pertains to him being involved with the Nazis. So like I studied basically everything except for what he researched. I just studied like him as an individual.
Hmm. I don't think he ran away from the Nazis. You know, he was not a Nazi sympathizer. He actually wrote a letter to President, I think it was Eisenhower, and told him to build an atomic bomb. Basically, he saved the West with that letter. He basically saved the West. So we got to give him credit for something. I don't like him. Lately, I've lost a lot of my respect for him and for people who quote him for some reason. But that letter was important. So I don't think it
But
was.
researching him having like autism, I thought was really imperative because I think that a lot of his views that have to do with electricity and um not electricity, sorry, gravity. I think that he might have just had an autistic interest in Sir Isaac Newton.
Not enough. He did not have enough of an interest. Like I barely had an interest, and I solved it. So
No, but if he had an autistic fixation, that would explain why like it was all based around like this one thing.
yeah, but I'm saying his fixation was insignificant. Like I figured out more than he did in just a couple of hours, which
Oh, sure. Oh, sure, but that's the thing about autistic blind spots.
so he.
You know, you'll come up with like your own facet of beliefs that have nothing to do with reality.
Oh, yeah.
There are autistic people who think that they're like otherkin, like you know what otherkin is.
No.
Apparently, this is kind of branching out and for some reason getting like new spiritual validity, but like some people refer to it as Therian, and it's when you believe you're like more animal than person.
Anyway, I don't think he was autistic. I mean, why would you say he was autistic?
There's a lot of people who do. There's a lot of research that supports it.
I don't think he would have been so dumb if he would have been autistic. I think autistic people are usually a little bit smarter than he was. He was actually, I think, a very good politician. So I think he's the opposite of autistic. I think he was extremely good with social skills. So good that he was able to manipulate the entire world to saying that he's some genius. He was like a. I mean, I don't have any good words to say about him. I mean, he was an idiot.
Autistic people can do that when they're pretending to be other people. It's like a form of like voluntary dissociation. I think that might account for some of like his ability to have a few social skills. But still, he came off really uncanny to me.
Hmm. Anyway, so why do you think an apple, when you let go of it, tends to accelerate towards the ground? Zach, Zach is back. Zach is
What's up,
back.
baby girl?
Oh my.
Wait, Zach, did you? Why did you call her that? You got to stop. Like you got.
I called you that.
No, she didn't know. I thought she was. I think she.
Sweetie pie, I was talking to you.
So don't. Like I don't like that either. You cannot talk this way. That's not. What's the point?
Make me
Why,
mod,
why would you
and I'll behave.
make you mod and you'll behave?
Yeah,
I
I'll
don't.
be like the I'll be like the goodest good boy.
I don't know. I don't see.
Sounds like a good deal if you ask me.
No, no, no. You gotta stop the nonsense. You gotta stop being inappropriate. Like on this server, please, I don't want anyone to be inappropriate. Like we're trying to be gentlemen, and we're trying to be scientific. No,
All right, sweet chick.
no, don't do that. Don't do that. Well, why would you behave this way? You're just being cringe. Why are you doing this? What are you getting out of this
My
behavior?
sweet pie. My sweet pie.
Do you
You
want?
have to calm down. Do I what?
Look, I'm busy. I'm in the middle of recording something. So,
Yo, slave, what did you say?
who are you talking to?
You said, do you want something? And then I didn't hear the rest.
No. Why are you talking this way after I asked you to not be cringe? Why are you
Do you
cringe?
feel uncomfortable?
Of course, I feel uncomfortable. Why would you?
Why?
It doesn't matter. Like when somebody says you make them feel uncomfortable, why are you continuing? What's the point? Why would you do that?
I'm so sorry, man. Please forgive me.
Yeah, just don't do that again. Just be normal. Just be normal.
Can you pray to Jesus with me?
Okay, I'm gonna ban you, and I think
I'm sorry. I'm sorry.
I don't get it. Why would you behave this way?
I'm deaf.
No time.
I'm disabled. I'm autistic.
All right, you're gonna get a. We're gonna start with a 60-second timeout.
No.
All right. Anyway, so uh, let's continue. All right. So we said there's no circle around it. So we just need the emitter, string to half mirror, string to full mirror, string to, no, this is display, string to full mirror, string to full mirror. And the display, you could probably have, you can add a camera, maybe, or a camera here, or maybe the best thing would be to add a camera here that's going to be looking at. So this is going to be a camera looking at, it's going to be connected to this. So it's going to be looking at the display so that we can analyze it, because we're looking for the wave interference, the concentric circles interference, black and red circles moving into each other or out of each other. So okay, so as this is going to be, so when it's sent out of the spaceship, you just throw it out and it starts rotating. And as it's rotating, it could rotate once a minute. I think that's good. It's a good rate, because we need to see with the camera. The camera is going to be transmitting the signal, the video, directly to Earth. So we're going to watch in real time the results. And okay, Zach, you got to behave.
I will. So what have you been up to?
You see, I'm talking about a space-based Michelson-Morley experiment.
Cool. Cool, cool,
Do you have any
cool.
questions?
Not really. I'll listen though.
Okay. Anyway, so yeah, the video camera is going to point at the display, but it's also going to it's going to overlook or oversee around the display so that we get a sense of the orientation. Maybe we can have more sensors about the orientation, the location, whatever. But this is just a basic form. Anyway, so it's
Yeah.
going to rotate, I would say, 360 degrees over 1 minute. Sounds like a good speed. It doesn't matter how fast. It shouldn't be too fast. If it's too fast, it's like spinning out of control. Uh, one minute. About 360 degrees per minute. That's the rate of rotation. I think rate of rotation is omega. I think omega is 360 degrees, like a full circle per minute. And we just need 90 degrees. That's all we need. So every 90 degrees, that's all we need. That should be enough. But of course, if we get 360 degrees, that's even better. Okay. And that's it. Well, what else do you want me to say? Okay, so, it has to be huge. So this needs to be a kilometer. So this is a 2-kilometer diameter, I think. For a 2-kilometer diameter, if we did the calculations right, so this is a 2-kilometer diameter. So it's a 1-kilometer arm. That should give us just a few ticks. I think 3 ticks per 90 degrees. Very minimal. So if you make it bigger, you'll get more ticks. Okay, the next we have the equation. What is our equation? Let's look at our equation from yesterday. Gravity is a fluid. Calculating n ticks. I think this is our most recent calculation. So it's about 2d per 10 to the 8th lambda, or 2d per 10 to the 9th. Oh, this is 0.2d. So this is 2d. I think we got rid of the d, so it's just d over 300. If we're assuming just a red light laser, it's about d divided by 300. So that's less than 1. The point is that over 90 degrees, you want to get at least 1 tick. So it's got to be at least 300 meters. D is the radius. So it's got to be 600 meters diameter in order to get 1 tick. Well, so make it. Now, if you double this, you can just double the number of ticks. So all I'm saying is, so 600, so about a kilometer gives you, so let's assume it's about 1 tick. So it's 1 tick per kilometer, I would say, of radius. It's about, I would say 1 tick, maybe a little bit more, maybe 2 ticks per kilometer radius. We got to go through the numbers. I mean, yeah, I mean, we can be accurate. There's no reason to be so inaccurate, I guess. The point is that the 650, because we're using 1-digit accuracy. So the 9 is really a 10, I think. So everything needs to be recalibrated because of the number of significant digits in the calculation. I think we're just using 1 significant digit calculation. So it's, if you want to have a more accurate discussion, you may, but it looks like a 1 kilometer per tick instrument. That's what it looks like for a red light. So here it says d, which is the radius, is 300 for 1 tick for 90 degrees. Now, by the way, if we rotate a full rotation, then that's even better. I think you'll be able to, as long as you can get more than 1 tick, I think you're fine. You'll see ticks. And for every rotation, you'll see a single tick. That's already proof. So that already proves the ether theory. So I would say 1 kilometer, this is 300 for 1 arm, 600 for 2 arms. I would say about 1,000 to get 1 tick or something like that, or just over 1 tick per 90 degrees, or 4 ticks per circle. So I would say at about 1 kilometer diameter, for 1 kilometer diameter, you get about 1 tick Sorry, you get four. Let's talk about 4 ticks per 360 degrees. For every 360, you should get. That's the number of ticks. I mean that is the ratio. This is one. So for every 1 kilometer diameter, you get 4 ticks. So if four ticks is enough, then that's the experiment you can do. If you want to get more ticks to feel better about it, if you want to get 40 ticks, so you want to do 10 kilometers, right? So you just multiply. This is a ratio. This is one. So if you increase the diameter linearly, you increase the number of ticks linearly. That's it. You 10 kilometer. But 10 kilometer, that's already very difficult to conduct because I don't think then you have to go to a very high orbit because you're going to have because there is air resistance even in these orbits. There's still air resistance. I think you have to go really high to start to lose like air resistance. You never lose completely air resistance. So don't forget that this equipment has very high resistance because a wire actually has incredible resistance. So if you look at the cross section of a wire, this is the cross section of a wire, or maybe this is the cross section of the wire. So when you have even the tiniest wind, you're going to get vortices. And this thing stops you, like it's very inefficient. Very inefficient. So the air resistance is going to bring this out of orbit very quickly. So it's not going to run for a long time. So if you want it to run for a long time, you got to shoot it up to a very high orbit. So I don't know how you would do that. I mean, you need a separate engine to bring it up to a higher orbit. But it's good enough. It's a good start to run this experiment in a high orbit. Okay, so that's one solution is a space base. Now, because I think we're talking about like 1 kilogram is about $1,000 these days. This is way under a kilogram. This could be, well, the wire is very long, so it could end up being a kilogram. But the wire could be really like a fishing wire. You don't need to have anything more than a fishing wire. A fishing wire is not going to last in space. So, but if you don't need this thing to last, you just want this experiment to run. The problem is if it detaches as it's rotating, some parts could endanger. It could become debris, space debris. So I don't know if you want to use fishing wire, which is like nylon or something. So you might want like a steel wire, very, very, very thin steel wire. Maybe that would last longer, but even that would give you a hard time. So anyway, you need to come up with, but it could be under a kilogram. And I think that, let me look it up on my Brave. The way it is price per kilo to orbit. This is low Earth orbit. I don't know if that's a good idea. So it's about $10,000 per kilo. I thought it's already down to 1,000. Oh, that's Antares. Falcon, yeah, it's 2,600, 2,700 with first stage recovery. So this should be a fairly inexpensive experiment. So if anybody can cover this cost, if you can cover this cost, I'll prepare. I mean, we're gonna need a GoFundMe, whatever. So maybe somebody should set up a GoFundMe. How would you set up a GoFundMe? Anyway, We need about $2,700 for 1 kilo of the equipment, but we also need to design the equipment, design everything around it, launch it, communicate with the data transmitter. So we need to test it. I mean, this is probably going to be 1%. I would say that this is about 1% of the total cost. So if it just this is 2,700, it's going to be, let's say, about 3,000. So I would say about $1 million. We need about $1 million. It's not me. It's anyone who does this. I think it's best if you first procure $1 million to conduct this experiment, because you're gonna need to, like, it's not so simple. It's not as simple as running it in the lab, but it would be incredible. Now, the next idea I had to conduct this experiment. So obviously, Michelson and Morley could not have done this. This is pre-World War II. World War II is the first time we had the V2 rockets. That's the beginning of the space race. And not even during World War II. We didn't reach orbit until after World War II. I think the Russians with the Sputnik reached it first. Okay. So. Very nice. Very nice. All right. The next step is the alternative. Let's think about an alternative. 1 second. Let me get back here. So let's think about an alternative to a space-based. What's going to be the name of this? This is going to be, right? This experiment needs a name. This will be the space-based Michelson-Morley Observatory or experiment. The space-based, so let's give it a name. This is the space-based Michelson. I need to scroll this up. Michelson and Morley experiment to discover the speed of ether. So sbmametso. If anybody asks you what is sbmametso, well, now you know. Or what are we going to call it for sure? I guess so. Why so? Speed of ether. This is the speed of ether observatory. The space-based Michelson and Morley experiment to discover the speed of ether observatory. Yeah, I think it's an observatory. Is it an observatory, detector, or whatever? I don't know what the last letter is. So it's o. It's the speed of ether observatory for short. Speed of ether observatory. The Soelo. Anyway, so somebody should take care of that. Anyway, what else do we want to say about the SOLO? That's it. That's basically. I'm pretty. You can redo the calculations before you send it. Maybe I made a mistake, so you got to redo the calculations. I still need to show you how I developed everything, like how I calculate the speed of space. I never explicitly, I went through it very fast in one of the debates, and I didn't really explain everything. We still need to do that, but that's well, okay. I mean, anyone can do it. I mean, but it is. I think it's the most important part. That is that is the theory of gravity, the proper theory of gravity, which is in conformation. It conforms to the Einstein field equations. I'm not saying that the Einstein field equations are incorrect. I'm just saying Einstein never understood his own field equations. No one ever understood his field equations because people call it curvature of space. That's not what it is. The curve geometry is the mathematical tool. The result is not the mathematical tool. The result is the flow of space, which is just the Gaussian. It's just Gauss's theorem or something. It's a Gaussian. It's it's the. I mean, what's his name? What is his name? Lenny. Lenny, Professor Lenny Susskind. So he says Leonard, Professor Leonard. I call him Lenny because I don't remember. Somebody called him Lenny, so I call him Lenny. I like him. He's a good guy. He's okay. He's okay. Just like everybody else. Just very wrong. I don't know. I mean, I don't know what's going on. This is the Emperor's New Clothes, where everyone is terrified of saying Einstein was a dummy dum dum. Just say it. You could say that he contributed. You can say many things. You just have to be honest. He did not understand. He did not come up with a gravitational theory. He came up with equations. He came up with things, but he did not, Isaac. He did not understand. I mean, he said he doesn't understand. I don't need to argue that he did not understand. He said he doesn't understand.
Where are you talking to yourself?
What?
Are you talking to yourself?
No, I'm recording. I'm recording.
My bad.
Yeah. So, anyway, good. So this is the Space Observatory, the Sowero Space Observatory. The next step is to try and conduct this experiment in a lab. So you might say, but how can you need the arms to be so huge? So the answer is there is an alternative. Okay, so this is going to be the high frequency light experiment. Right, okay. So high frequency. So based on the equation, if we go back and look at the equation that the people, developed this equation. So the final equation is, this is not the final. So before we plugged in lambda, so you can look at this and you have 2d over lambda 10 to the ninth. So let's take this equation. This is 2d. And of course, the next thing is if we can, right? So right now, lambda for a red laser is 0.65 micrometers. But if you can make this smaller, then you can make this number bigger. This is the number of ticks over a 90-degree rotation. And right now, we're using a red laser. The arm needs to be 300 meters to get one tick. So maybe we can take this and make lambda smaller than 0.65, maybe 10 times smaller. And then we just need 30 meters, which is still huge. But that's already possibly, doable for, I don't know, like there's buildings this big. So maybe we can do it, but still it's going to be an issue with the actual stretching and bending of the materials. So we can overcome that with stress sensors, and we can calculate whatever stresses and stretches are occurring and neglect those and calculate them and remove them as interference. So we know the errors a priori using material science, which I happen to know a little bit about from a. I'm not going to tell you how I know.
Yeah.
Hmm. But that's if you get a wavelength that's 10 times smaller than red light. But if you can go 100 times smaller, then you can go with a 3-meter arm. And if you can go with 1,000 times smaller, then you can go with a 30-centimeter arm. That's basically the size of the original Michelson-Morley experiment. It looks like it was about a meter arm, maybe a little less. So, so can we find light that is or electromagnetic radiation that is 1,000 times smaller wavelength than red light? So let's take this. Let's create high frequency. So let's paste that here. Do you have any questions, Zach? Wait, what do you mean question mark? How did I
No, I don't. Not at this time.
how did I copy a question mark? But do you have any idea what I'm talking about? Look at this question mark. Anyway, I just want this equation. We can memorize it. It's 2D. Oh my god. I'm so sad. I made so many mistakes in such a short time with such a good chick. I'm so bad. So bad. All right. So high frequency. Let's try
Can
paste.
I ask a personal question?
You can ask, but don't make it cringe because I'm gonna like don't be cringe. Why would you want to ask me a personal question? What's the point?
So, has your girlfriend ever pegged you?
I'm not gonna discuss that. Anyway, so let's remove this.
All right, moving on.
That's fine. Okay, so let's remove this and this. All right. So, uh, so we have. So this is n. This is the number of ticks. So we have already discussed what a tick is. Oh my god, it's so cool. It gets cold and hot and hot and cold in seconds. Stop. Oh, the battery's dead? Wait. What's going on? I can hear it. It's broken. The switch is broken. It's not stopping. Maybe the battery's weak. Stop. It's not changing speed. It's beeping. The light is turning on and off. All right. What am I supposed to do? So every time I want to turn it off, I have to get up? That's impossible. Oh my god. I'd rather kill myself. Okay. Anyway, so there's no point here. It's not point two. Wait, oh, there is no point. Okay. Right? There's nothing there. Oh, there is something there, but what? Oh, it's a dot. Okay. No dot. All right. Let me see. Yeah, everything is okay. All right. So 2D over this. So let's change. All right. So let's assume. Let's aim for one tick. Let's aim for one tick. So this is. If we want one tick, then what is D? Let's assume we want the answer to be 1. Give me one tick for 90 degrees. That's a good start. Then we can, it's linear, we can multiply it. It's linearly proportional to D, so we can always increase D. Okay, so if this is 1, then then D. Yeah, we want to see what D is. We want to make D. Okay, let me first find light that is how small can a light wavelength be? That's the question. How small is the minimal wavelength light? So let me Google this. So Brave it. So Brave. Uh, Search the web privately. How do you search Brave or type? Okay, so search Brave. So just light wavelength, just the light spectral or spectrum, just the light spectrum. Just show me the spectrum of the light. Something like this. Zach, you're 1 second. Let me share the tab. Yeah, what's the question? No.
What does Pookie mean?
What?
What does the word Pookie mean?
I don't know.
Me neither.
Okay. All right. So share this tab. Okay, what do we got? So let's go. What is this image? Is this one? The try dark mode. I've been trying, but why don't you keep it dark? Okay, here it is. So, ultraviolet. Okay, look at this. So visible. This is micrometer. 6, 7, 8, 9, 10. Good. So we can use X-ray. So this could be X-ray based. We don't have to go X-ray. We can go between X-ray and ultraviolet. We can go 10 to the negative 9. So this is micro. The next step, I think, is nano. Micro is divided by 1,000,000. Nano is divided by 1,000,000,000, I think. So we just need nano wavelengths. Nano, you can see, I guess, atoms. X-ray, you see atoms. Nano, this is not nano. This is 10 to the negative 8, you see a molecule. X-ray can see atoms. I didn't know that. And gamma can see atomic nuclei. So I don't know how to get gamma. I mean, you just need a very fast oscillator to oscillate your antenna, because you just create, right? This is all created by a radio, by like a radio tower. At this point, the radio tower gives off visible light. It's like burning. It's like a lamp. Here, it's burning so bright we cannot see that this brightness is beyond our ability. This wavelength is too small for our eyes. And this is too small for our eyes, but this already damages our DNA, because you're destroying. I mean, you're bumping against the atomic structure of the DNA, and you're creating mutations in your DNA. You're ripping your DNA. So if you hit the telomere, the end, there's something in the DNA strand that has a telomere or something, that could tell the cell to divide endlessly, and that's dangerous, obviously. So this equipment is dangerous. So don't mess around with this equipment. But if you can, so just don't be in the room. But I think you can just you should be able to buy an ultraviolet emitter, because they were doing ultraviolet. Einstein got his Nobel Prize for the ultraviolet. Right, they were shining ultraviolet light on metal and seeing Let me see the battery on this thing. Do I have? Oh my God, it's the expensive batteries. Jesus Christ, I have very few of them. Totally terrible. Okay. I can't believe some people they design equipment based on very expensive batteries. Why would you do that? You can base your equipment on the cheapest batteries. Why would you base your equipment on super expensive batteries? Every time I need to replace a battery, it's like $1 for a battery. What's the point? And these die all the time. Oh my god. Anyway, so there used to be so Einstein got his Nobel Prize for the photoelectric effect with the ultraviolet light. So it shouldn't be a problem to create ultraviolet. They used to do it 100 years ago and more. So this is doable, in my opinion. Let me get this message. What happened? Oh, this is from tonight. Oh my god, I wish I could play it. Wow. Yeah, I can't play it. I already got a strike for playing music. They give you a strike so quickly, it's ridiculous. Yes, Zach. No, you said something. You can listen and try to understand and pay attention and give me feedback. Tell me if I'm wrong, Tell me your opinion. Do you find this stuff interesting, the least bit interesting, or is it completely boring to you?
To me, honestly. Yeah.
All right, then I don't know how you can help me. You can help me by by paying attention and like debating me on it, debating me on this topic. Tell me if you think I'm right or wrong. It's really
I
very straight.
I find it difficult to debate because you talk too fast, and I'm deaf.
I'll talk slow. What do you mean? But do you understand what I'm doing? Do you understand the experiment? Do you understand where I'm going with it? Why I'm so excited about this experiment?
No, because you talk too fast.
Okay. Do you know why an apple falls from a tree towards the earth?
Yeah,
Why does it do that?
I don't know what you said
No, what do
because you
you
talk
think?
too.
No, what do you think? Why does an apple accelerate towards the earth? Why does it do that?
Oh, I have no idea.
So, this is what I'm trying to answer. This is what this experiment is about. It's
Yeah,
simple, yeah. This experiment is a violation of special relativity, general relativity, quantum mechanics. I mean, it's a new way to think about everything. It's a more mechanical way to understand all of modern physics. This makes modern physics much less magical and much more mechanical. So this can actually result in quantum mechanics, just like the name suggests, instead of quantum magic. Anyway, look, if you don't care, you don't care. If you don't care why an apple falls off a tree towards the earth, that's I don't know what to tell you. Anyway,
no, Pookie Bear, I don't care.
okay, it's fine. I'm gonna continue researching this. I'm going to switch to another tab. Okay, so we see here. So we need to go from -6 to -9. We can also go to just straight to -10. And if we go to -10, that would be fantastic. So we could use an X-ray. It's just dangerous, and I don't know. Like you can't be in the room while you run the experiment, so that's not fun. Where ultraviolet, you may. So you can we're talking about -9, which is just below -10. So maybe you can still be in the room and not be afraid to get cancer, or you can conduct the experiment. Yeah, go ahead.
The air smells like arse.
What?
Yeah,
I didn't understand what you just said.
the air smells like arse.
I don't know what that means. Look. If you want to say something interesting, say something interesting. But you keep saying nonsensical things. So, like, we can debate a normal topic, but you gotta debate like no, a normal topic, not nonsensical stuff.
I just find it difficult to debate you when you talk so fast.
I'll talk slow, but you gotta like say something wise. Don't say something dumb. You're
That's so disableist, bro.
What are you talking about? Okay, I gotta get
Is
back
it
to
because
my
I'm
work.
autistic and deaf?
I don't know what you're saying. I gotta get back to my work because you're boring. You're not trying to be interesting. You are
That's
well.
rude, man.
What?
I said that's rude.
No, no. I'm not saying you're a boring person. You keep bringing up topics. So when you bring up an interesting
Can
topic,
I ask you one thing?
yes.
What's your favorite food?
No, no, we're not gonna discuss that. No.
Quickly, what's your favorite food?
No, ice cream and pizza.
You like pizza?
Of course. Who doesn't?
I had that today.
I haven't. I'm on a diet. I'm just eating a little bit of protein here and there, and that's it.
Why is your girlfriend fat shaming you?
No, I'm tired of being fat. I need to lose weight. I gained a lot of weight over time. I found out that pants that I bought my last trip I can't wear. That is an inconvenience. So that indicates that when I at that time that I was not thin. I'm still much fatter now than I was then. That's unacceptable to me. So I'm cutting. I'm in a cutting cycle.
Why not just buy new pants?
No, no, because I want to be normal. I don't want to have so much. I don't want to carry so much fat on my fat.
But you're beautiful just like the way you are.
That I don't know what that means. I don't care.
Like you're
I don't care. I want to be.
beautiful just the way you are.
Yeah, I want to be thin. It's nothing to do with anything. I just want to be thin. Like I don't care if I'm
But
beautiful
you're
or not.
perfect the way you are.
I don't know what that means. I just want to be thin. I'm tired of being fat.
But you're beautiful to me.
All right, I'm gonna put you on timeout if you if you start being cringe again. All right, let's go. I'm busy. I'm busy. Stop it. I'm busy.
Can I say
No, no, I switched tabs, so no one can hear you. So stop. All right, let's continue. No, stop. All right. Okay, I'm gonna put you in a timeout. So, all right, no one can hear you. 5 minutes. Bye. All right. So, so this is good. So I would say before you get to extra, I would say yeah, 10 to the negative 9. You should be safe. Hopefully, like let's see if at 10 to the negative 9 we're still safe. So, um, what is the shortest wavelength that is still safe? I mean, remember that what is unsafe is the fact that at this point, you're scrambling your DNA. That's the issue. So I think that 10 times bigger than an atom, you're not, as long as you're not knocking off atoms off your DNA, you're okay. So ultraviolet is molecular size. That's like probably DNA size. You're not going to harm the DNA. So that's okay. But the question is what happens 10 times smaller? That's already getting too close for comfort. So gamma rays gamma rays are the shortest wavelength and highest energy form of electromagnetic radiation with wavelengths ranging from zero point zero 0.01 to 10 picometers PM. They are ionizing radiation capable of damaging living tissues and causing harm if not properly shielded. Safety consideration. The safety of gamma rays depends on the intensity and duration of exposure. Prolonged high intensity exposure can cause radiation sickness. Okay, but I'm not talking about gamma ray, I'm talking about X ray. Anyway, the question is 10 to the negative 9. Is 10 to the negative 9 is 10 to the negative 9. What do you call that? That's a nanometer wavelength. Is a nanometer wavelength dangerous or safe? What does 390 nanometers peak wavelength mean in the context of whatever? So the 390 nanometer peak is outside of UVA, so this wavelength is invisible. However, a peak wavelength, unless it is monochromatic, has a bandwidth. I don't know what they're saying. The question is 1 nanometer. Is 1 nanometer dangerous? What is meant by wavelength in nanometers for light? A wavelength is a quantitative property of waves. Is it safe or is it dangerous? Can you just tell me that? Dangerous. Donguru. Donguru. Is it donguru? Donguru. Is nanometer wavelength dangerous? Based on the search results, nanometer refer to wavelengths in the infrared region. It's called infrared? Isn't it ultraviolet? Infrared is -5. What do you mean? What's going on? That's like huge. That's not even visible. What's going on? Who wrote this? It's not. Nanometers refer to wavelength in the infrared region of the electromagnetic spectrum. The wavelengths mentioned in search results specify 850, 1300. That's 1,000 times a nanometer. That's called a micrometer. Oh my God. Fiber optics and are not ionizing. These wavelengths, including infrared and visible light, are considered non-ionizing. What about ultraviolet? Ultraviolet gives you not radiation, it gives you sunburn. Comparison for context, ultraviolet radiation, which has wavelength between 10 to 350 nanometers, is ionizing and can cause harm to living tissue. X-ray and gamma rays with even shorter wavelength are also ionizing and can be dangerous. Anyway, just put the whole thing in a steel cage. I think ultraviolet cannot penetrate steel. So just put it in a steel cage. Even aluminum probably doesn't even. Can you block? I think you can just leave the room. Usually they just leave the room. It's not like the room has any special insulation. Can you get X-ray? Wait, you don't see this. So anyway, I don't care. Yeah, you can figure it out. The experiment if it could be tiny. So if we're talking about something so tiny, so now we know the answer. Lambda could be very tiny, but then you wouldn't see it. Oh no, you don't see it. How can you see the interference pattern? How would you see the interference pattern? Oh my God, that's a problem. So how do you see ultraviolet? You already have a problem seeing ultraviolet interference pattern. So that's kind of useless. Oh my God, let's look it up. All right. Can we see nanometer interference pattern in an interferometer? In an interferometer. Oh, so we can use like a normal interferometer. Can we see nanometer interference pattern in interferometer? Interferometry is a technique used to measure tiny changes in phase, amplitude, or position of light waves. In an interferometer, light waves from two or more sources are combined to produce an interference pattern, which is a result of the superposition. Visible light, okay, for visible light, I can't see. Oh, I can't magnify it? It doesn't magnify? Okay. For visible light, e.g., white light, the interference pattern is typically not observable with the naked eye due to the following reason. Yeah, visible light, white light, you can. Wavelength of visible light is relatively large compared to the distance involved. I don't know, what do you mean? The phase changes induced by the interferometer's components, mirrors, are typically too small to produce visible interference patterns. Really? Not with a laser. Nanometer scale interference. However, when working with shorter wavelengths such as laser light, near infrared or ultraviolet, or using specialized techniques like high resolution microscopy, scanning near field optical microscopy, I don't know what that means. Optical coherence tomography, I don't know what that is. It is possible to observe interference patterns at the nanometer scale. So that's what we should do. In these cases, the shorter wavelengths and higher resolutions enable the detection of subtle phase changes, allowing for the visualization of nanometer scale interference pattern. So nanometer visualization of nanometer scale. That's good. There is the Michelson interferometer. In a Michelson interferometer, the movable mirror can induce changes in the interference pattern, but these changes are typically not observable at the nanometer scale with visible light. However, with laser light specialized techniques, it may be possible to detect nanometer scale changes in the interference pattern. Okay, it's just a little dangerous, so put it in a box so you don't get X-ray coming out or whatever, or any dangerous rays coming out, and you should be fine. The equipment should be the same. So since we were asking for $1 million for the space observatory, I think it would be better to conduct it in lab with nanometer wavelengths. Then it could be relatively small. Let's do the calculation. So let's talk about a 1 nanometer. Let's say it's 1 nanometer. So it's right. So you can already see you get 2 ticks for 1 meter. A nanometer, a 1 nanometer cancels this 10 to the 9. So then it says 2D equals 1 tick. So D could be even half a meter. This is right. So it's a 1 meter station. The 1 meter device, or the half a meter. This is half a meter. It's 1 meter. So it's one. So half a meter. It's kind of small, smallish. Altogether, it's 1 meter. It's a 1 meter device, 1 meter radius device. That's basically the size of Michelson's device. But this has to be inside a box because you're using nanometer, which is close to X-ray. So you don't want that coming out at you. But that should be good. So, um, so lambda equals 1 nanometer. This means ultraviolet to X-ray. It's between ultraviolet and X-ray, approximately. What do you want? Oh my God! I wish I went there tonight. Genie. All right. So for this lambda, at this lambda, these cancel out. Well, it's basically 10 to the minus 9 meters. So at this time, these two cancel out, so you just get 2D equals 1. So 2D equals 1. So D equals 1/2 meter. If you can go X-ray, it could be even smaller. But that's already, I don't know. I don't know if you want to make such an expensive setup. Okay. All right. Okay, so that's it. So that's probably the cheaper solution. We should probably do both. Why not? But the space observatory, I think it's an overkill because it's going to be so expensive to get this right, and it's not expensive to shoot it to space, but it's a lot of work to prepare for that, to build the equipment, and the what do you call it? What do you call it when not the lift off, but you need to install it in space. You need to run a space installation, like a completely autonomous space installation. That's you need to build a robot that will you know unfold itself and send out the wires, make sure it's rotating and stuff. It's a hassle. So it would be easier to use the high frequency instead. But again, this he could have done. This Michelson could have done. And again, he didn't think that far. I mean, which is incredible because, he had many years to think about it. In 1920, Einstein already said that the ether is gravity. It's just that it's not moving. But at this point, they should have said, "All right, let's test again Michelson vertically. Let's use high frequency, even X-ray." It's just I don't know what you would see. I don't know what the detector is going to see in such a case. I honestly don't know. What display can you have? Like you need. I don't know what sensor. You got to look into this because I don't know. I honestly at this point it's getting very technical, and I still want to keep my theoretical hat on. I don't want to waste too much time in the details of, in the engineering of the experiment. As much as I want to be an experimentalist, if I have the budget, I might get into it, or if I had the people to run the experiment, I could instruct them and, we could work at a lab. If somebody gives me access to a lab, I'll manage the experiment hands down, no problem. But I'm not going to do so much work on my own with no help at the same time that I want to figure out all of quantum mechanics because I still need to figure out quantum mechanics and I still have questions about, hey Zach, about
And what's up?
relativistic mass. Hey, what's up? Well, how are
Long
you?
time.
Yeah, man. It's good. It's good to have you around. You're keeping me not sleeping, keeping me awake. You thought of
That's
something
good. What
interesting.
time is it for you?
I
What
cannot.
time is it for you?
I cannot disclose that information. I'm sorry.
Well, for me, it's 9:27
So you're in England?
p.m.
Are you in England?
Yeah,
That's cool. Oh yeah, I heard you yesterday guessing at. Are you in London?
yeah.
That's cool. Anyway, you gave me some peace and quiet, so I was able to figure out a lot, like in two complete experiments. One is a space observatory that's probably going to cost about $1 million to put together, and another is a probably X-ray based equipment, like a test, like X-ray based interferometer. Let's give it a name. So this is X or the nanometer. This is the nanometer, the nanometer Michelson and Morley experiment. Well, experiment to discover the law, speed, you know, of what? Of the ether. So the last four letters are tote. Sot. So this is the sot, the speed of the ether. The sot, the speed of the
Can I
ether.
ask you something?
Yes, sir. The nanometer sot. This is the nanometer sot. This is the nanometer sot. Speed of ether. Speed of the ether. Yeah, it's much better to have T for the. Speed of the ether. The nanometer sot. NM sot. Yeah, what's up?
Do you believe in God?
God is not a scientific proposition. Well, if God is a non scientific proposition, then that's the end of that. And if God is a scientific proposition, then, well, we can scientifically test this proposition. So, either way, it's not about believing. I don't have any room to believe whether I want to or not. Why do you care?
Okay.
Why do you care about God?
Because I want to save you from hellfire.
Yeah, that doesn't make any sense.
Yeah, yeah, I want to save you from hellfire.
By being cringe? Then why are you so cringe? The first step is to just be a gentleman like me. See, I'm trying to save you from hellfire too. From believing false beliefs, from being
Can I
unscientific.
tell you something?
Sure.
So, so the other day, my girlfriend who pegged me.
Okay.
So, like, it felt really good. I might ask her to do it again.
That's great. That's really terrific.
Yeah, I just had to share it.
I'm sure. I mean, I've shared this discussion before. It's actually very important to have this discussion. Let me see. A person must find and reach not. Let me see. Judas. Join us. This world is a prison realm, and Gnostic sets you free. Well, I don't know. Hey, Judas. How are you, Mr. Judas? So, you're muted, Judas. You're muted. Much better. So,
Hello,
yeah.
how are you?
Hey, terrific. So you're not gonna believe
Not this voice again. It's turning me on again.
But
I'm not trying.
Zach, if you want to have cringe conversations, do it in private. Come on, it's cringe. I don't like hearing about
All
it.
right, call me on private, bro.
No. I want Judas. I want to tell Judas, and then maybe I want to have a discussion with Judas. So we were talking about important stuff today, so I'd rather have an important conversation with him. But it's up to Judas what he wants
You're
to do.
stealing it from me.
No, it's up to Judas. Whatever Judas wants to do. What do you want to do? You want to
Yeah.
talk to Zach or me? What's your preference?
I'll just leave. I don't like choosing between people.
No. Like, okay, so you guys.
Bro, you sound like you picked me up.
I have an idea. Okay, I'm gonna.
I sound like what?
Okay,
A pick me up.
okay,
What
I'm
does that
going
mean?
to. Okay, listen. I'm gonna stop my stream. You guys talk. I'm gonna take a break. I'll be back.
Okay.
And Judas, I'll talk to you after you're done. All right. The end of the stream. You know what? Yeah, I'm just gonna leave the room. Okay, goodbye. All right. So, we're still streaming. Good. I can still go to a private room and talk. Let me just make a concluding remark. So, we discussed two potential methods. Potential, as Anton Petrov says, potential. It's like there's not, since I noticed that he always says potential, There's never a video he doesn't say potential a few times. We have a message. Sub, do you read this? Carlos Paiva. Yes, I read. I read comments. Unfortunately, 11:30, so it's 3 minutes old. Unfortunately, YouTube never lets me know that there is a message. So I there's no notification. You know what? There is a notification, but it never works. Like there is a studio. I have the studio app installed in my iPhone, but I never get a notification that there is an incoming. Wait, we're down to 173. We're losing subscribers. Oh no, no, no! We can't be losing. Video blocked. Research: did Einstein know about Michelson-Morley? Oh my God! All right, so yeah, but there's no notifications. Let me see. Policy analytics comments. Policy. Just policy. Okay. Just analytics. Okay. And comments. Okay. What is the server link? Sebi should get a life. That's from 3 weeks ago. 4 days ago. Logical vegan. Well, science shows that you don't understand logic. Partly joking. All right. I don't know. So this message that you, oh, there's another message. Laugh my ass off, sub. Oh my God. Okay, that's good. But so you just subbed. Let me see if it shows up. Let me see if it shows up. Oh my God. Content analytics. Earn. Yeah, I'm still far from being able to earn 173. Can I refresh this? 174. Yeah, they saw you, Jawbreaker Gaming. They saw, they added you. Total subscribers. Very nice. Is very nice. Anyway, so in conclusion, oh, 2 people watching live. Here, let me give you the link. So if you want to enjoy a discussion, you can join me. So the name, right, smallest Michelson-Morley experiment that we can construct and get a positive result for. So the answer is that we try to build 2 experiments. One in space, based on red light. We saw it needs to be the minimum is about a kilometer diameter. It's going to be a major hassle. I don't recommend it unless you don't get a positive result, because so the second option is the infrared or the nanometer SOT, the search, I don't remember SOT, the ether, speed of the ether, the nanometer speed of the ether test. So that the problem there is you cannot see, it's outside of the spectrum of what's visible light. So you can't see it unless you can somehow slow it down. So what you could do, but I don't want to interfere with the data. I want the original data, because you could slow it down. I don't know what's going to happen if you slow it down. How would you, stretch the wavelength? You need to stretch the wavelength of the nanometer. So after the nanometer is influenced, in order to see the interference, you can stretch the wavelength and see it. The question is, how would you stretch the wavelength? So how can you stretch the wavelength? I don't know. Unless you have a very, very fast detector, but maybe an analog, you can convert, if you can convert the signal, if you can detect a signal, I don't know if you can detect it, but if you can build a detector that can detect, then you can see the 2 waves. If you can attach a scope, and because I think that at those wavelengths you should be able to induce electricity, so it should give you an electric signal. I don't know if I didn't I don't know if X-rays give you an electric signal. I know that ultraviolet gives you an electric signal, but so you might be able to get an electric signal for the detector. And then you can literally see the waves. I mean, you can see the waves in a scope. In a digital scope or an analog scope, you can see them. You can see the waves. You can see the patterns. You might be able to see them. Maybe, I don't know. So in that case, you can see the fact that you wouldn't see an interference. You would just see, yeah, you would see an interference. You would see two waves, and then they merge into one big wave, and then they would destructively interfere. You could see that. That would be great. Yeah, yeah. So there you go. Anyway, look, this is very technical. You gotta know your laboratory stuff. So I'm gonna try and put my hands. Now that we know these numbers, I'm gonna try and get my hands. Let me just modify the email that I wrote. So sent. I still didn't get an answer from this lab manager in a local university. Okay, so I'm gonna need to tell him that after. Maybe I'll write it in English. I don't know. So after checking or okay, after another calculation, I discovered that I would need to use the source of light cannot be a visible light. So it's gotta be light nanometer wavelength, ultraviolet. How do you say ultraviolet? Ultra. Yeah. So if I tell them I need to use X-rays, they're gonna tell me to go fly a kite. So I'm just gonna tell them I just need a nanometer wavelength light, like ultraviolet. The question is how am I going to see the interference? So in order to see, so I'm going to need access to a scope. How do you say scope? I think they only have digital scopes these days. Scope. So in order to see this light, I'm probably going to need access to a scope. It's not just the light. Can you see ultraviolet? Is there glasses to see ultraviolet? I think there's video cameras that you see the heat of the body, and you could see the heat. So you could see the heat signature. I don't want to ask them for too much. They're going to read this. They're going to say, okay, this guy's asking for way too much. I'm just going to tell him I need access to ultraviolet light. That's all. If he says yes, you know what? I'm not going to tell them. If they tell me come do the test, then I'll tell them, great, I'm coming over. Just one question. Do you have an ultraviolet lamp? Well, is there an ultraviolet laser? Let's Google this. Let's Google. Let's Google. Is there an ultraviolet laser? Oops. Ultraviolet. How do you spell laser? UV lasers operate in a wavelength range of 140 to 400 nanometers. That's too big, emitting extremely energetic radiation that interacts with the chemical physical properties of materials. This characteristic makes them suitable for various applications, including precision machining, marking, and microfabrication. Okay. Anyway, look, whatever equipment they have is fine. At least I know, like, even these numbers are too big. Even 10 nanometers is too big. Like 1 nanometer is already huge, right? So we don't have access. These guys, can I get access to see? I don't want to hear them talking, these guys, but I need access. Okay, so I'm just going to turn off join. I'm not listening. I just want to watch the whiteboard. What did we conclude? What did we conclude? Dude. There it is. So, yeah. So the arm is half a meter. So the whole thing is 1 meter. And that's for 1 nanometer. Oops, here. I wanted to show you this. So for 1 nanometer. Wait, are you able to hear me? I guess. How's the audio all this time? Mirror, mirror on the wall. Yeah, audio is good. Okay, so the question is. The question is. Okay, I mean that's way too big. That's 400. That's 400 meters. Come on, stop. Oh, so that's gonna give me. That's 150 meters. 400 meters. That's useless. How could that be? We said. How could that be? How could that be? I don't get it. Don't get it. Don't get it. Don't get it. Ultra, blah, 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 blah. Right? So we said micrometer. Micrometer is 6. So that's 1,000. That's 1,000. Right. So nanometer, well, 400 nanometers, half a micro. That's already red light. Red light is 0.65 micro. So it's about half a micro. That's about 400 nano. That's useless. It's just under red. Oh, it's just under red. That's all it is. It's useless. 150 nano is 150. Well, it's for every nanometer, it's 1 meter. So this is 150 nanometers. That's it. 150 meters. It's 1 to 1 nanometer. It's 1 to 1 nanometer. So we need 1 nanometer. 1 nanometer is crazy. 1 nanometer is X-ray probably. One nanometer light. What is 1 nanometer light? 1 nanometer light. What? Nanometer? I don't care. Nanometer. Nanometer is often used too. I don't care. Nanometer light. Convert nanometer to light year. I don't care. What type of light is nanometer? What do you call the light? What is it called? Nanometer light name. Is it X-ray? Forget it. It doesn't matter. Here it is. It's too cold. Here it is. Nanometers between these two. Between 8 and 10 is 9. It's not X-ray, but it's not ultraviolet. So that's it. That's all you need to know. It's just between, just borderline X-ray. So I'm not gonna ask them for anything. I'm just gonna tell them, give me what you got. Now, can I create my own X-ray? How can I create my own X-ray? How do I build an X-ray? How can I build my own X-ray? I want to build my own X-ray. How would I do that? Based on provided information, here is a step-by-step guide to help you build your own X-ray machine. Materials. X-ray tube. Thank you. Just buy an X-ray tube. Congratulations. X-ray to alligator clip, 5-10 units depending on the brand. Can I just buy? Is there X-ray for sale? How to build? Together, Matthew and Blake took home. Let me see a YouTube video where they build an X-ray machine. Can I just YouTube build X-ray machine at home? Build X-ray machine. Built my own X-ray.
Hi, I'm William, and I'm $69,210.32 in medical debt. Well, it was fun while it lasted, little willies, but I'm gonna have to start selling all my stuff to pay this medical bill. Anybody want this ballistics gel hand from the garbage disposal video? You want to buy this garbage disposal? We're gonna do a little garage sale. Classic American insurance. How about a laser baby? A toy fire truck that was used to train Jimmy Neutron to put out fires. Add that to the pile. This is one of my most prized possessions. It's George W. Bush Top Gun action figure. I bought it at a swap meet like 2 years ago. I guess I can get rid of these too. A bunch of Michael Reeves merchandise that he abandoned and left with me. I bought a bunch and then never sold it, and then now they're mine. Every single Michael Reeves nut shirt.
How did you get such a bill? Like, an X-ray is usually like $1,000 if you pay out of pocket.
Electrical and mechanical, and I would love to build my own medical equipment to prove that $69,000 is insane.
You don't need to. You can just go to the vet. Like, when you get an X-ray for the dog, it's $100 or something. So you just go to the vet. It's the same equipment. Done and done. You just buy equipment for a vet. Build your own vet office for cheap.
Pooping in a litter box. And I'll sell anything I have in order to pay for this debt. But right now, I can't build my own medical equipment because I have more important things to do.
You can probably buy an X-ray machine, a used X-ray machine from like a doctor's office. This chick is, I'm sorry. I'm so sorry. I would not be interested in such a chick. I mean, she, okay face, but I cannot help her.
Dollars?
No, we have medical insurance.
Whoa! I'm only $2,500 in debt instead of $69,000. That means we have plenty of time and budget to make an X-ray machine in the garage. But I only have one question. Why did the hospital bill so much more money than they were ever paid? The hospital tried to bill me $69,000, but only got paid $11,000. Insurance steps in and says, "Geez, nuts, we're not paying $69,000. So that makes insurance the good guys, right? Wrong, Philly boy. The reason hospitals charge so much is because they know insurance is going to lowball them. The problem is hospitals treat uninsured people the exact same way. What you're supposed to do is the same thing that insurance does with hospitals. You fight them. You tell them no. But I've done.
Yeah, that's ridiculous. what you need to be able to do is ask them beforehand, how much it's going to cost. And then they say, well, we don't know. We can only know after. It's like, it's so ridiculous. They don't tell you before. So once I was just before a flight and I had to get this done. And I asked them, what's it going to cost? They said, the guy that can do the calculation is not here. So I had to get it done before the flight. It ended up being like $1,000. It was really ridiculous.
Had bought on eBay. I just had to drain a bunch of oil and rip off the broken high voltage circuitry.
But how does it work? I mean, all you need is an antenna, a high frequency antenna, which is just like a light bulb, just a very high frequency light bulb, no?
You pound sand. I have health insurance, and my will to do science is significantly stronger than my will to live. No, I'm just trying to say that I would rather do science and die than not do science. All we have to do is get the high voltage out of the danger box and into...
Okay, I don't care. I want to know how it's supposed to work. No, not like how to build it from scratch. I don't want to buy anything from scratch. How do you build it from scratch? I made my own X-ray machine. Like, how did the ancient ones build it?
Just see straight through the mirror. To answer this, I tried to sneak a mirror into my doctor's appointment, but they caught me.
Hold up. I just gotta.
What is that?
It's just.
No,
to
you
see.
can't have.
So if we're going to test this out, we're going to have to make our own X-rays. I heard that some researchers had made X-rays using triboluminescence of Scotch tape. When you unroll a roll of Scotch tape, both sides of the tape that unstick become electrically charged. So electrons can jump off of the tape and fly to the other side. These electrons will sometimes knock into air molecules along the way. And whenever an electron changes momentum, it shoots off a photon. In this case, they have such high energy that they can actually shoot off X-rays. This type of X-ray creation is called Bremsstrahlung radiation. It literally translates to braking radiation because it's the radiation that's emitted when fast-moving electrons slow down. So to test for X-rays, I'm going to be using this radiocode detector, so I can actually measure the energy of the X-rays coming off of it. It's a spectrometer for radiation. So I have some Scotch tape here, and I'm just going to pull it really fast and see if I measure anything.
Grab it and pull it.
So pulling tape on X-ray?
What? It actually is measuring something.
Is this an
Look
iPhone?
how high it went.
Oh, this is.
But I have a hunch that something's up here. I shouldn't be able to create X-rays this easily. I know that Geiger counters can actually be sensitive to static electricity. So let's try electrically grounding the detector and see if it goes off. So I'm just going to put some steel wool over this that will kind of protect it from the static. Nope, nothing. We just hear background radiation. Well, that's actually a little reassuring that you don't get X-ray shooting off whenever you use some tape. The problem here is that the electrons have to gain speed between the two pieces of tape. When we have air around us, then the electrons immediately bump into the air and don't gain any speed. So in order to do this, it has to be done in a vacuum. But unfortunately, even when I tried it in my vacuum chamber, it still didn't produce X-rays. The problem is that even though I'm at low vacuum, you need a really low vacuum to make the X-rays. I'm at about 0.1 millimeters of mercury, but after reading into this more, we need about 0.001 millimeters mercury vacuum to make X-rays. So this isn't going to work with tape. This is an old half-wave rectifier. This is how they used to convert AC to DC. You can see inside the tube there's this metal cylinder, and at the center is a sharp metal rod. When you plug it into AC power, the rod at the center gets hot. And when the voltage is largely negative, then the electrons fly off of the rod to the positively charged cylinder around it. But when the voltage on the rod is positive, then the positive charges can't fly off the rod, so no current flows. So you only get half the AC wave, and you end up with pulsed DC current. But did I mention one thing? The inside of these bulbs is a very low vacuum. This makes it so the electrons can get from the rod to the cylinder easily. But this is exactly what I need. If I can charge up the rod to a high enough voltage, then I should be able to shoot electrons off so fast that it makes X-rays. But in order to do this, I can't just use a normal voltage from our outlet at the house. We need over 100,000 volts. But where can I get a voltage that high? Well, I'm going to be using my Windshurst machine. I have a separate video where I talk about how this works. I'll link it in the description. But when I crank this handle here, these two spheres get charged to very high voltages. What's nice about this machine is that the voltage is very high, but the current's still small. So it's not going to kill me if I get shocked. So I'm just going to hook it up here, and I'll put it behind these bricks to protect me from the X-rays.
I don't understand.
Okay. See, this is the kind of stuff.
Can't they just tell us how they used to, how they discovered the X-ray machine? How difficult was the original one? Okay, I don't care. I mean, this is not. We don't need this right now, so it's not important. Okay, we've been here for 2 hours. I think it's enough. We got some work done. I think we're heading in the right direction. I think we should go back to the analysis. I think we should go back to analyzing the theory and quantum mechanics and try to figure out quantum field theory, maybe a little bit more about Michaelson-Morely, even though I'm pretty confident, like assuming all the equations are right. I'm curious about E equals mc squared. What is that all about? What does that even mean? I don't even know what that means. What is E equals mc squared? What does that come to say? I don't understand. Maybe we should look into that, because we've discovered everything is so nonsensical. Maybe that's nonsense too. Because when they have an atomic bomb doesn't change matter into energy. It just releases. I mean, it just releases right, the strong force. It just breaks down the strong force. It breaks down uranium or plutonium, whatever. These are just you just have a chain reaction. All you're doing is you're not turning. I mean, they just become lead, right? It's just you're turning uranium into lead, like uranium 265 divided by 2, whatever number that is. That's it. You're just breaking it in 2. You're not breaking it into more than 2. So each part, I think it's like 225, so it's 160. I don't know what the numbers are. I don't know what. No, it's got to be under 100. I think it just turns into lead. I think uranium is the number of neutrons might be high. That's why it's enriched, I think, with neutrons. But I don't think E equals mc squared means anything. I don't know what the point is about E equals mc squared. We need to look into that. That's the first order of business, maybe. So let's just make a note. First order of business is look into E equals mc squared. Do I believe it? Do I believe E equals mc squared? Where's the notes for next time? Next time, E equals mc squared is correct question. Okay, I think we're done for today. I mean, done for now. All right, everyone. See you next time.